Hello, 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 everybody, and welcome back. Root Beer here, looking at question number 23, the very middle question of the Part C questions on the 2007 Fermat paper. That's the grade 11 multiple choice paper. And let's take a look here. We've got an ugly light fixture, apparently. So an ugly light fixture is hanging from point O, okay, there we go, on the ceiling. Wires OXM, OYN, and OZP pass through the vertices of a thin wooden equilateral triangle. It certainly doesn't look like it in their picture, so we'll add in the little lines here. Equilateral triangle XYZ, side length here is 60. A small bulb is attached to the end of each wire. Okay. I guess that's what makes it an ugly light fixture. I don't know why this information's in brackets. Anyway, the plane of the wooden triangle is parallel to the ceiling. Again, it does not look like it, but fine. If each wire is 100 centimeters long, and the lower end of each wire is 90 centimeters long, so we got 10 centimeters left up here, what is the vertical distance between the wooden triangle and the ceiling? So C to the wooden triangle. That's what we're looking at here. We want that distance. Alright, so the wires hanging down doesn't really help us at all. I mean, it's extra information. All we need is the 10 here. Okay? So, it's three-dimensional geometry, and I've got to confess, I've never been that good at these sorts of ones. But let's see if we can sort of think through it, reason through it. And this is exactly the sort of time where I'd say, you know, if you remembered to bring scissors, we're allowed to bring scissors and some extra paper, start cutting out, you know, a little sort of sample diagram or something like this and trying to piece things together, just so you understand what's going on here at a three-dimensional level. What can we do here? I have... See, this is why I don't just keep them up for show to make myself look smart. I actually have some solids here. Props are fun. Okay, so sort of O, it's hanging from the ceiling. It's going straight down. And we've got our equilateral triangle. Now, I know these are the same length here. But sort of imagine these are 10 centimeters. But because the wires are going through and they each hang down 90 and the length that's left, so here's O, X, Y, and Z here. Each of these is 10. It's not like O is going to be, sitting mostly close to X or anything. O is going to be sitting right above the top, and that's, I think, the key thing. It's going to be, sorry, not right above the top, right above the middle. O is right above the middle of this triangle, okay? Because all these lengths here are 10. They're all the same. So O isn't pulled towards any of them. If one of these were shorter, yeah, O would be closer to that side, but we're not looking at that. And sort of that's the three-dimensional geometry coming in, is can I imagine this? Where should O be relative to our base equilateral triangle? And that's the key, okay? So anyway, that's enough with me and my little Rubik's Cubes. So let's see here. So we've got O. Each of these is 60. OX equals OY equals OZ. So O should be right above the middle or centroid of the triangle. We might give that a nice purple color. So it doesn't look like it, but O is going to be right above. So the shortest distance between the triangle and O is going to be this perpendicular distance, this height. And that's what we're interested in. Okay? So, three-dimensional pictures are all well and good. Having three-dimensional props is fine. But we need sort of this reasoning. And really all we need are things like a top-down view and a side view. So when we have our top-down view, O and the center of the triangle match up perfectly. Now it's tempting to label these lengths that I'm drawing, you know, OX, OY, OZ here. It's tempting to label them as 10, because that's what we expect them to be out here. But we're sort of looking at them sort of from the top down. If I can borrow another prop I happen to have handy on my desk, you know, this pencil here, quite long. But if you take a pencil at home and you look at it from the side, yeah, quite long. But if you look at it down on an angle, suddenly you only see sort of the tiniest little bit. So lengths looking down or from the side can indeed be misleading. Okay? I'll look at my second screen and I'll see if I can do that to you guys. So long, but now as I keep it sort of stable, you know, the vertical height here on the camera is starting to shrink until eventually it kind of looks like just a dot. So you can't trust that the 10 that we know OX and OY and OZ are is going to translate to our top-down view. That's a two-dimensional representation. Things get stretched out, things get squished. We have to be aware of that when we're drawing these pictures. So we actually don't know the apparent length of OX and OY and OZ. They'll all be the same value, but they likely aren't this wonderful little 10. Okay? And figuring out what the apparent length of OX is actually going to help us a little bit. Because if we look at a side view now, I'm gonna put X and Y and Z are gonna sort of look the same, and O is gonna be up here. But if I look at flat on from the side, I get my purple height H. Now I know that the hypotenuse here is 10, and this length here is the apparent length of OX. Okay, that's what we're actually figuring out here. And we break it down like this, one, because two-dimensional geometry is so much easier to work with, and two, now we sort of get our plan of attack. We want H. Well, I can't get H by looking at this three-dimensional picture all day. I can't do a thing with that. But when we start to switch into two different views, top-down view, we start to realize, oh, O is just sort of a point here. There's no H at all. I can't see H anywhere in this picture. But I do have this OX, and oh, it's different than this 10. And we look at the side view now, I can see the relationship between 10 and this length down here, and how they relate to H. Okay? So now the question is, how do I get this blue length? Because H is just, 10 squared minus the blue length squared, square rooted. That's, basic Pythagoras here. Okay? So we've changed the question from what's the height, what's the distance between O and the wooden triangle, to what is the blue length. As soon as we have that, we've got everything. Okay, well, we do a little more work. I think we'll need a bigger one than that. It's always sort of hard reasoning through these three-dimensional geometry questions, and I find now as I'm doing these videos and I'm teaching them, it's hard for me to explain my reasoning, which means I still have a long way to go as sort of an educator when it comes to three-dimensional geometry. So we've got O here, and what can we do? We got our blue length, but this is going to be the same for all three of them. Okay? And O is the centroid, so our blue length is the distance from the centroid to a corner. Okay? And it's an equilateral triangle, so one other thing we can do is we could actually, let's use the dark blue, we could extend this line over here, and it's actually going to split and give me a right angle. Okay? So if I want this blue distance, maybe call it B, well, suddenly I've got B, and then I've got a B over here, And I know the side length of this whole thing is 60, so if we split it in half, we get two 30s. Okay. Not only that, we split 60 degrees is the angle at the corner. Well, now I've got two 30 degrees. 30 degrees is, a full 60 degrees here. This is going to have to be a 60 degrees. And things start falling into place. This is a 30, 60, 90 triangle. Okay. We got 60 over here, 30. So B plus this other bit, maybe we'll call it D. B plus D is 30 times root 3. It's the side opposite the 60 degrees. So this is going to be 30 root 3. But down in this smaller triangle, B is the hypotenuse and D is the one opposite the 30. So we can say quite confidently B is twice D. So now I've got 3D is 30 root 3. D is going to be 10 root 3. And then bringing this equation back in, B is going to be 20 root 3. Okay? So it looks like B is 20 root 3. That's our sort of apparent length here. Okay? So we got 20 root 3. We have 10 as our actual length here, hypotenuse. But hold on a second. 20 root 3 should be this down here. 20 root 3 is bigger than 10. I can see that quite clearly because root 3 is bigger than 1. So have I misread something in the question or misreasoned? And that's entirely possible. So a very thin wooden triangle, size 60 centimeters. Each wire is 100 centimeters long, and the lower end of each wire is 90 centimeters from the ceiling. Oh. Wait a minute. 90 centimeters from the ceiling. So, I just thought this bottom part here was 90. Oh, so how many of you were smacking your heads and screaming at the video when I just read through that too quickly? Okay. So I might have to redo the question now. So the panel of the wooden triangle is parallel to the ceiling. Fine. If each wire is 100 centimeters long, then the lower end of each wire is 90 centimeters. So it's not the lower part. So I can't say that that's 10. But what I can do is I can say, so this height h, this down here is 90 minus h. And so then this is 100 minus 90 minus h. Or h minus 10. H plus 10. Okay, so I can salvage it a little bit. I still have the same relationships. I don't have a side length of 10. OX isn't 10. OX now depends on this H here. Okay, so it's not 10, it's 10 plus H. 10 plus H. Okay, that actually didn't change a whole lot. We still have this equilateral triangle. We're still going to be solving for H here. So now we can say, okay, we have H here, we have 10 plus H here, and we have 20 root 3 here. I'm getting the feeling that there might be another 30, 60, 90 triangle here. Maybe this is 20 and something. I don't know. But let's just use Pythagoras and get this all sorted. So 10 plus H squared, our hypotenuse, is h squared plus 20 root 3 squared. And now the root 3 is going to go away. So we get h squared plus 400 times 3, or 1200. And over here we'll have 100 plus 20h plus h squared. Now we'll get our magenta. The h squareds are going to cancel. 100 is going to cancel over here. We're going to be left with 1100. So 20h is 1100. Divide by 10 on both sides. 2h is 110. H is going to be 55. And I saw 45 and a couple other integers, so I have to believe h being 55 is one of our possibilities. There it is. So 55 centimeters, and so that means that 35 is the length of xm and that sort of thing. Oh, I'm glad I caught that. I knew something was going wrong. 10 should not be the hypotenuse there. So that gives us an answer of D. I do apologize for misreading, but that does happen. It might happen to you at some point when you're actually writing these. It certainly has happened to me every once in a while. But yeah, there we go. Question number 23 done. We move forward. We feel bad for misreading and wasting time after the contest. Put that out of your mind. We do question number 24, question number 25, and we do them with a smile on our face because we're still confident. I will see you guys for question number 24 in the next video. Feel free to give it a shot before I get to it.